Okay, so to find the absolute extrema, or the absolute maximum and minimum of this function, as usual, first we're going to find the critical points. And then the second thing is we're going to compare the values at those critical points with the endpoints. The values of the function at the endpoints. Okay, so the first thing we need to do is to find the first derivative, because that's going to give us the critical points. So the derivative of the natural log function, we have to use the chain rule because we have x squared plus x plus 1 inside. So what we're going to have is 1 over the inside, leaving it alone, times the derivative of the inside, which is just 2x plus 1. Okay, and if I rewrite this, I would get 2x plus 1 over x squared plus x plus 1. Okay, so remember that to find the critical points, what we need is to figure out all the places where the derivative is both undefined and equal to 0. So since we have a fraction, well, we have to be careful with the denominator and figure out where it equals to 0, but a quick check of the discriminant. Remember, the discriminant is in the quadratic formula, the inside part. If you look at this, this is equal to 1 minus 4, which is negative 3. This is a negative number. That means that this quadratic equation has two imaginary solutions. So that means the denominator can never equal 0. So the good thing about that is that we don't have to worry about the denominator or the derivative being undefined. We just set the numerator equal to 0. Or, well, let's do it this way. You set the entire thing equal to 0, but since the denominator is never equaling 0, then you can multiply both sides by the denominator. And get rid of it. So here on the left, the denominator is going to cancel, and then on the right we're just going to get 0 times anything is just 0. So 2x plus 1 equals 0. That means that x is equal to negative 1/2 is going to be a critical point. And that appears to be our only critical point. And so if we compare, so now we're on to step 2, compare the values at the critical points with the values at the endpoints. So we're just going to plug it in. So when x is equal to negative 1/2, y is going to equal to the natural log of 1/2 squared plus 1/2 plus 1. And for this we're going to have to approximate it with a calculator. So we'll leave that for a tiny bit and plug it in. But then we're also going to plug in our endpoints. So when x is equal to negative 1, y is equal to natural log of 1 squared plus 1 plus 1. So this is natural log of 3. Sorry, that was for positive 1. Okay, and then when x is equal to negative 1, y is equal to natural log of negative 1 squared plus negative 1 plus 1, which is natural log of 1, which is just 0. Okay. And so if I approximate these guys, what I'm going to get is Okay, I just realized that I made a little sign mistake here. I forgot to put in the negative here. This is supposed to be negative. So this is going to be natural log of 3/4. Sorry about that. And if we approximate it with the calculator, it's going to be negative 0.29. And natural log of 3, well, this is the largest number because it's the biggest argument inside of the log. But if we find an approximation, it is approximately 1.10. And well, the third one is just 0. So if we compare all three of these, we would say that the absolute maximum occurs when x is equal to positive 1 and y is equal to 1.10, and the absolute minimum occurs when x is equal to negative 1/2 and y is equal to negative 0.29. And that's it. And sorry for the little sign mistakes over here.